Good morning, ladies and gentlemen. I would like to invite you at this presentation about Healthy School project. And let's start with the basic information. This project started at the end of last year. We prepared the implementation and we collect data since February this year. And the goal of this project was to help to the school to analyze indoor air quality for students during classrooms. And one of those measurements were made inside of the building. And as a reference, we also collected data from outdoor air quality and also noise, because it's school which is located in the city center. So let's go to some information about air quality. And I would like to ask my colleague, Mr. Žáček, who is owner of the Protronix company.
Hello. Yeah. Thank you. Good morning, ladies and gentlemen. My name is Miloš Žáček, and I'm from Protronix Limited Company. And we provide to our customers design and production of industrial electronics, and we make design and production of our own products. And one part of our products are internal air quality sensors. So I am here to brief you, or to very briefly inform you about the problematic of internal air quality. You can see here some graph. I will explain a little bit about it and why to bother with internal air quality at all. And I think there are a lot of reasons and a few main reasons, and one of them is that today we live in more tight buildings. Everybody wants to save money for energy, for heating or conditioning of air. So we use the more tight windows, more tight doors, etc. And then we put some thermal isolation from the outside of the building. So in the end, I sometimes like to say we live in some submarine, because they're really very tight to save the energy on one hand. On the other hand, we need to ventilate and to take care for air, because it should be really problem in some tight building or something. A second reason is that on average we spend about 80% of our daily time indoor. So it's very important. And when I was thinking about this, I realized, oh my God, that during the winter days, I sometimes spend almost 100% indoor. So you see that it's very important to take care for internal air. And next reason is, as you probably know, roughly we eat, let's say, per day about 1 kilogram of food or something. 2 to 3 kilograms of water we drink in average, or some liquids or something. And guess how much air we use per day? In average, it's 15 kilograms. So you see that quality of internal air is very, very important. And what are the main pollutants of the air? And in this case, it's shown that it depends on the source of pollution. And we discussed the school here, so the source of pollution of the air, internal air, are the people, human bodies, which are inhale and exhale. So main parts of the pollutant of the air are so-called volatile organic compounds. So it is some organic compounds where there's up to 10,000 different types of volatile organic compounds. And then some germs, bacteria, ammonia, etc. Some odors, smells, you know what it means. And at the same time, goes high the CO2 concentration, carbon dioxide concentration, but CO2, carbon dioxide itself, is not the main reason for why we should ventilate. Main reason are the volatile organic compounds and other things like dust or something in the air. But CO2 is very, very good for judging actual quality of air, because CO2 concentration is proportional to the main pollutant of the air. You can see on the graph that the pollutant in the time goes up, so at the same time CO2 goes up. So we use CO2 as for judging actual internal air quality. You see here on the graph some reaction for ventilation of the system. So CO2 goes down, at the same time goes down the VOC. So it's good to measure CO2 and then control ventilation. On this picture you can see the people, a few people are in the house, so the concentration of CO2 goes slightly up in time, and in the case there are more people, so this curve is more steep, so it's possible to use CO2 for judging the ventilation, especially in schools where there's a lot of people, students in some very small room in comparison to how many people are there. And how is measured CO2? Basic principle is very simple. In practice, to realize it, to do it is not so easy, but basic principle is very simple. There's some source of infrared radiation, and there's some optical chamber in which is the air with the molecules of CO2, and there's a special infrared radiation on special frequency, special wavelength, which collides with the dimension of the CO2 molecules, and there's a receiver and there's an optical filter which lets go through only the special frequency of infrared radiation. So the output on the detector on the receiver is proportional to the actual concentration of CO2. So this is a so-called NDIR method. There are different methods, but this one is very good, very, very stable. I mean, in long term. And you can see here our sensor inside. This is this optical chamber is this small gold box. This is a sensor which measures actual concentration of CO2, relative humidity, and temperature. And you can see here IQRF radio module, which serves for transferring data from the sensor to the cloud. And this is the sensor with the front cover. Here are some indicators, LED indicators, which the green one means like it's echo, it's very good concentration, low concentration of pollutant, and you save the money for energy, etc. And now, in which units is CO2 measured? It's measured in so-called ppm, means parts per million. It's similar to the percent. Percent means 1 from 100, from Italy per cento. And this means ppm, 1 ppm is 1 from million. So if you have here in this example one red ball, and amongst 1 million of all balls, so it's 1 ppm, just for example how it is, what means 1 ppm. And what's the some scale of CO2 concentration? Outside is usually something about 400 ppm. Every year is going up. Last year, I guess it was 403 ppm. It was the first time it was more than 400 ppm. And up on down on the scale is about the 400 ppm. And up, it's not here, but it's 50,000 ppm. What is the concentration of the air which we exhale? So we inhale air outside, which has about 400 ppm, and we exhale air which has about 50,000 ppm concentration of CO2. Means like 100 times higher. And between that, you can see here some level 800 to 1,000 ppm. So this is recommended value. At this value of CO2, we know that the concentration of pollutant of air is low, is comfortable to stay in such area, no problem at all. Above that, above 1,000 to 2,000 ppm, it starts to be a little bit not so comfortable. It's individual. It depends on everybody, how does it feel. But it could start some feelings like not to feel so comfortable, a little bit, maybe you know these feelings like a little bit, you feel a little bit hot, and even despite the fact that the area or air is not so hot, but you feel a little bit hot, so it's some manifestation of higher CO2 concentration. Above 2,000 up to 5,000 ppm, sorry, here, it's a concentration of CO2 which tells us that the pollution of the air is really high, so it's necessary to start to ventilate or to do some action or to leave the space or something. So you can have some manifestation of some dizziness, to feel some headache, or to have a lower ability to concentrate on something, etc., and to feel sleepy a little bit. So that's some manifestation of the high concentration of pollutant and CO2. So here is on the picture is how could be if the concentration of the CO2 or pollutant in the air are really high. I'm sure that let's put aside regarding our school system, let's put aside some study technology, but I'm sure that part of problems regarding our school system is low quality of air in the classrooms. Thank you very much. I will ask my colleague to continue to show you some actual data from this area, from this room. Thank you very much.
Thank you. And as you could see, this was about real partnering, because I told to Mr. Žáček, please speed up a bit, because we are eating a lot of time. So, are you aware of this room? Do you have an idea how much pollution or how much CO2 you were able to create in this room? If it will work, you can see an example of Protronix measurement, because in that side you can see two sensors. There is also IQRF network, and thanks to our IoT data platform, we are able to see data in real time. That's just an example. And as you can see, we are in good condition, and you can feel fresh. That's pretty good. And let's come back to the school. How they are doing. Before I will show you some results, there is information about the simple implementation. We have two sensors. We have IQRF gateway, which is running with resin, and then there is a common connection to our IoT platform, which is in production and serves also other projects, and we used Grafana to visualize real data. How was the installation at the school? As you can see, it's not complex architecture. It's not something groundbreaking. But what we proved, it is, let's say, groundbreaking, because we have IQRF network. We have installed Protronix sensors to 10 classrooms. We measured two sides of the building with outdoor air quality sensors and also noise, as I mentioned earlier. And all this data we collected, stored and normalized in IoT data platform to have the information on one place. Some conclusion. As I said, it's not groundbreaking infrastructure, but on the other hand, we used technology which is ready for large implementations and massive installation of complex devices, let's say in the world, in terrain. This is something what I mentioned. It's based on resin. Resin and similar technologies enable us to do such kind of implementation and management and administration of those complex devices as IQRF gateway is. And On the other side, the IoT data platform have responsibility for collection of all data and identification of all non-standard and operational events which can happen. And also what we expect from that platform is immediate visualization of real data we receive. And with integration with, for example, as it was used in this case, with Resin, SaaS solution, we are able to manage and monitor devices implemented in terrain. One component, one puzzle, as Shimon said at the beginning of today's presentation, is missing. Just think about it. We as a service provider have to think big, have to think about large implementations, about high number or large amount of devices operated during their all life cycle, during end-to-end operation. And that's device management which has to help to such implementations to run such large implementation properly. So, what we have prepared for our workshop, which is today at noon in the workshop room, is an explanation of the software stack, the software components which you can use or which you can think about are necessary to use for such implementation. My colleagues have prepared live demo and they would like to show you what they have prepared, and they are also ready to discuss with you all details of this project. Some data. If you want, you can comment it. Okay, I will. What you have seen here, what you see here is a presentation of measurement during 2 weeks. It's about temperature, and as you can see, we have 2 weeks. On the vertical scale are dates, and on your left side is midnight, and here is the end of the day. And you can see each day, each school day, hour by hour, temperature in the classroom number 7. You can see that there are for example, three interesting occasions. The temperature changed dramatically. That means there were windows open at the classroom. Fine, that's the temperature. Let's see what happened with relative humidity. What was the impact to relative humidity? Again, if the ventilation with open windows was enough, then you can see that the humidity also changed and decreased a bit. And what happened with CO2? Of course, go ahead.
I want to say something regarding CO2. If you don't mind.
Sure.
Yeah. Okay, so because CO2 is our interest, the most interesting thing is CO2. Temperature and relative humidity was a little bit out of some expected range, or range which should be. And regarding CO2, you can see here very nicely, like there's a weekend, Saturday, Sunday, so there's no rush in school, so the values are very, very good. And you can see some red or dark red moments where the concentration was really, really very high. And again, here are some moments where there was some ventilation. I guess it was mechanical.
Mechanically, yeah.
Somebody opened the window, so you can see very nicely how was influenced by opening the window, and the fresh air from outside went inside. And there's a demonstration even of some, as I mentioned at the beginning, regarding how the buildings are tight. So you can see how many hours takes to naturally ventilate this room in one day here from the concentration about 3,000 ppm, and it took very long time to go to some natural outside value. So you can see that how important is some ventilation, how the ventilation can improve indoor air quality. So we can continue.
Thank you. Based on the information, if they will have it online, then they are able to, that's the Thursday, the red part, and they will definitely also open the window. That means the information, right information at the right time could help in the existing building, because this building is historical. They have no chance to change too many things, and this is why they wanted to see what's the life within the building. And just for your information, the red is not enough, because on the right side you can see the scale, the color scale, and you can see that from the green it goes to bad numbers. So some final results, some final numbers. All 10 rooms were monitored. This is just the final calculation of figures, and simply said, more than 47% of the time, of the school time, is with more than 1,000 ppm of carbon dioxide, which is an interesting number. Regarding temperature, there are some limits, some regulation of temperature for schools, and we can say that we measured that more than 27% of the time was with temperature above 26 degrees of Celsius. And finally, if I have hot environment, the humidity goes down, and that means they have less than 30% of the humidity, almost 2/3 of the time students spend in the school. So some hard figures to see that it's not just a game. There are some real results which we share with the manager of the school, and that's basically what he was expecting. If you want to comment those numbers, you can do that for sure.
Okay, so what we see, let's say at the beginning we expected that the numbers will not be so good. So this is some, let's say, valuation of our expectation. So we expected that the numbers will be similar this. Sometimes we were surprised it was good, and sometimes we were surprised it was too high, even a little bit more regarding our expectation. Thank you very much.
Yeah, and finally, the puzzles, because we are unable to do that alone. We are the system integrator. There is an expert, vertical expert on the indoor air quality measurement, and there are other colleagues and other partners who participated on this project. Thank you.
Thank you very much. Have a nice day.